Hello everyone, welcome to my channel. I hope you are all doing well. Today I'm going to show you what is one sample t-test and when we use it and how to interpret this test by doing an example. Here you can see our example, but we need some requirements before doing the test. One sample t-test is a kind of test that is more likely to run because in the real world it is highly unlikely that we know the standard deviation of the population. So, one sample t-test is conducted when we don't know the standard deviation of the population. It is also a parametric procedure. And in one sample t-test, we test whether a sample mean is significantly different than a population mean. So, a basic database for a one sample t-test works like this. We have one sample group from the population. Our dependent variable is a scale measure of this sample. We know the mean of the population. And we know the mean and standard deviation of the sample. However, we don't know the standard deviation of the population, and we're going to estimate that from our sample. The independent variable is also one sample, which is categorical data, and dependent variable is a scale level variable with a mean. What is important here is that every test is built on some assumptions, so we need to check those assumptions to make sure they meet before doing the test. And here are the assumptions. The first assumption is that there is no extreme outliers. If there are outliers that causing problem, we need to exclude them or erase those outliers. There are three ways to find out outliers, but we just check the first one. And they are IQR, interquartile range, Turkey's method, and box and whiskers chart. But what is an outlier? An outlier is defined as being any point of data that lies over 1.5 IQRs below the first quartile or above the third quartile in a data set. You can calculate them just by hand or by Spss. Here we're going to calculate those by Spss. So go to Analyze, Descriptive Statistics, Explore, and put our variable of interest in dependent box, and then click OK. And as you can see in the result, within the table descriptive, you can see that interquartile range is listed here, which is 3.88. But we need first quartile and third quartile as well. So to do so, go to Analyze, Descriptive Statistics, Frequencies, and BMI, drag BMI into the box, Statistics, Quartiles, Continue, and then OK. So here in this box, 25 percentile is first quartile and 75 percentile is the third quartile. To find out the outliers, we multiply our IQR by 1.5 and then see whether our data are within this range or not. So as you can see, upper limit here is 33.57 and lower limit is 18.055. So we have no outliers here. And the second assumption is there is no missing data. But in our data set, we have two missing data, but you will see that in Spss, it automatically will input all missing data from your data set. And the third assumption is that all our dependent variables are independent. which means that scores in one part of our sample does not affect the scores in other part of our data set, which here all our dependent variables are independent. And the last assumption is normality, which says that the dependent variables are normally distributed. But if our sample is not normally distributed, we need to use a large enough sample to satisfy the assumptions of normality based on the central limit theorem. To find out whether our dataset is normally distributed or not, go to Analyze, Descriptive Statistics, put it in Dependent, and choose Plots, Normality Plots with Tests, and Continue, and then OK. As you can see in the table Tests of Normality, you can see the results of two tests of normality, Kolmogorov-Smirnov and Shapiro-Wilk. And you know that if significance value is greater than alpha value, which is 0.05, then there is no reason to think that our data differs significantly from a normal distribution. So here our data set is distributed normally. So for our example, all the assumptions are met, but how this test works? Our null hypothesis here is sample mean is the same as this population mean from which is drawn. We show it by H sub 0 colon mu equals mu sub 0, where mu sub 0 is the population mean. And the alternative hypothesis is writing as H sub 1 mu does not equal mu sub 0. And alpha level is typically set to 0.05. And in t-test, we need the degree of freedom as well, because we want to estimate the population standard deviation, which is equal with the number of our data minus 1, which means one less value free to vary. And so the critical value is based on degree of freedom and alpha level. We'll look up a critical value in a student's t-distribution table. I will pin it in the description and you can have it. So let's get started and do our test. Here I'm interested in variable BMI, body mass index. Especially I want to know my participants have higher or lower BMI than the average BMI of our community of 60-year-old residents. We sampled these people from a certain neighborhood and want to know how they compare to the average 60-year-old residents of the city. So here I have one group of people that I have measured one time. And here Spss calculates the mean for my sample and then compares that sample mean to another certain mean. And to do this, it uses one sample t-test. So go to Analyze, Compare Means, one sample t-test, put our variable BMI into the box test variable. And here we need to set our hypothesized population mean in this box labeled test value. So imagine that average BMI of 60-year-old residents is 28.4. Here Spss is going to calculate the mean of our sample and then compare it to the known value of 28.4. So click OK. The first table contains the descriptive statistics. We see mean, standard deviation, and standard error of the mean. And the second table contains the inferential statistics. So as you can see, here is the t-score and also the degree of freedom and the p-value, which is indicated by SIG. And in general, there are three ways that we can determine if one mean is statistically significantly different from another mean. The first way is by looking at t-value. We would go to a table called student t-table, as you can see, and look up a critical value. If the t-value is larger than the critical value of that table, then the means are different. And second way is to look at the p-value, which, as I said, typically the cutoff for the statistical significance is 0.05. And here, any values equal with 0.05 or less are said to be statistically significant. And the third way of determining significance is to look at the confidence interval. We are testing a hypothesis that the mean differences was 0. So, if the 95% confidence interval includes 0, then the means are not different. So, here in our example, I looked up the t-value from the student's t-table two-tail test. And as you can see, found out for our test with 9 degrees of freedom, the critical value is 2.262, and our calculated t-value, as you can see, is minus 3.041. But here there is something that you should notice, and it is that when the amount of t-value is negative, then we treated it as its positive counterpart. So here we consider the absolute t-value, which is 3.041. And as you can see, it is larger than 2.262. So our null hypothesis will be rejected. Also, p-value here is 0.014, which is smaller than 0.05, which means that it is statistically significant. And finally, lower confidence interval is minus 4.39 and upper value is minus 0.64. So this confidence interval does not cross the 0, so means are different. Therefore, these three findings all telling us the same thing, that the mean of our sample, 25.88, is different from our average of residents. So our hypothesis will be rejected. And that's how we do one sample tests in SPSS. I hope you enjoyed it. In the next videos, I'll explain other tests and other forms of t-tests. Thank you so much for watching this video.